I want to build an app that can scan handwritten code from an image and run it. But there is a huge problem. You see, I am pretty shit at programming, so I did what any normal person would do and asked ChatGPT if he'll marry me.
Hey, Whispering Rizzler 123 here. After searching for a while, I came up with a general idea of the app. The app itself will be based on Flutter. All the links will be in the description, by the way. The actual scanning, compiling, and executing will be done on Python. It will only work on C and C++ for now, because Python has indentation. Yeah, we love Python. Anyways, for scanning and extracting the text from image, I will use optical character recognition, or OCR for short. Oh look, Python library based on Google Tesseract OCR, it must be good, right? No. I tested the OCR using 3 images. Screenshot of typed text, picture of the typed text, and picture of handwritten text. I also added an accuracy calculator to check how close the detected text is to the original text. The OCR on the first image worked fairly well with a good accuracy score. On the second image, however, it did not perform as good, but still not that bad. It did detect a 0 as a 1 though. I don't know how. And finally, on the handwritten text. The fuck? See, it took me way too long to realize that OCRs are not good at detecting handwritten text. I still blame Tesseract for wasting my time. Well, guess I have to find another solution. Google Vision API that looks cool, and it's pretty accurate according to GPT. So I downloaded the API key, installed the Python library, and wrote a simple program to test it on the same handwritten image. Damn, that's pretty accurate. I still hate Tesseract though. The compilation function was pretty straightforward because my app only supports C++ as of now. It uses the subprocess library. The function just saves the code to a file named code.cpp, compiles and executes it. If either the compilation or execution faces an error, it returns the error. If not, it returns the output. The capture_output parameter is used to capture the std out and std error output of the subprocess, and the text parameter just specifies that the output should be returned as text. Let's test the compilation function on this sample code. Nice. Before we move on, here is a brief overview of the app. User will select an image and send it to the server. The server will scan it and return the scanned text back. User will check if the extracted text is accurate, and after removing any errors, send the text back to server. Finally, the server will compile and execute the code and return the output. I know the app from a security standpoint is pretty shit, and I will do absolutely nothing to improve it. Let's move on to Flutter. I asked GPT to make me a simple Flutter app with a text field and 2 buttons. Here's what it looks like. Look, I want it to be functional, not pretty, okay? To make the buttons functional, I added an image upload function and a run code function. The image upload function prompts the user to pick an image using the image picker Dart package. If the user actually picks an image, it changes the text in the text field to loading and waits for the upload image function in the API service class, which we will get to in a second. After receiving the response from that function, it updates the text field with that response and some additional comments. The run code function sends the current text in the text field to an API service class function, and upon receiving the output, it updates the text field again. The API service class will be responsible for sending the requests to the server. The image upload function will upload the image selected by the user and wait for the response. If an error occurs, it will return the error. If not, it will return the output. Compile and run code function is the same. It sends the text string received in parameters to the server and waits for the appropriate response from the server. This base IP address specifies that the request generated should be sent back to the same machine, and 5000 is the port number. So the image upload function will send the request to this URL, and run code function will send it to this URL. Now to actually receive these requests, I use the Flask library on Python, which runs specific functions based on the URL being requested. This just makes a new folder to save the received images. Let's test the entire app now. I will use this image. Let's go.